Hi everyone. Let's take a look at number 6 on page 196. Find the value of k that gives the function f of x equal to x squared plus kx plus 2 a local minimum of 1. Step 1. To find a critical point, you have to find the derivative and set this to 0 and solve for x. So in this case, if the function is x squared plus kx plus 2, f prime is going to be 2x plus k, which means when you set this to be 0 and you're solving for x, you can bring k to the other side. That becomes negative k. The opposite of multiplying by 2 is to divide by 2. So the critical x value is going to be negative k divided by 2. Now, if you think about the minimum value of 1, this just means the y value is going to be 1. That's what the word value implies. So if you go back to the function y, which is f of x, that equals to 1. So you can express this as 1 equal to, and again, instead of plugging in x, you can rewrite it in terms of negative k divided by 2. So in this case, 1 equals to k squared divided by 4 minus k squared divided by 2 plus 2. To solve for k, the opposite of dividing by 4 is to multiply by 4. So you can multiply both sides by 4. So now 4 equals to k squared minus 2k squared plus 8. If you bring it to the other side, this means k squared minus 2k squared is going to be negative k squared. 4 minus 8 is going to be negative 4. The opposite of multiplying by negative 1 is to divide by negative 1. And k equals to plus or minus 2. So again, don't forget there are two cases here. Now, how do we know you're doing it right? You can go back and double check. So if you really go back and say, well, is it really plus and minus 2? The function equals to x squared plus 2x plus 2. And if you think about the vertex, again, you can use completing the square. You can put this in factor form, find the midpoints. You can use the shortcut, h equals to negative b over 2a. It's really up to you. But again, if you apply the shortcut, again, ABC just means 1, 2, and 2 respectively. That's going to be negative 2 divided by 2 times 1. That's going to give you negative 1. And if you plug negative 1 back in, the corresponding y value is going to be 1 minus 2, which is negative 1, plus 2, which is 1. So that's correct so far. Likewise, if you check the second case, f of x equals to x squared minus 2x plus 2. H, in this case, is going to be negative b over 2a, which means it will be positive 2 divided by 2 times 1. That's going to be 1. Now, if you plug it back in, though, that's going to be 1 squared minus 2 times 1 plus 2. And again, that's going to be 1 minus 2, which is negative 1, plus 2, that's 1. And that's how you know k is equal to plus or minus 2. Let's keep going. Number 7 on page 196. For the function x to the 4 minus 32x plus 4, to find the critical numbers, the intervals on which the function increases and decreases, and all the local extrema. Use graphing technology to verify your results. So, again, step 1. Find the critical points. When you take the derivative, that's going to be 4x cubed minus 32. You're going to set this to 0, and you're going to solve for x. Common factor of 4, you can bring to the front. In the brackets, it's going to be x to the power of 3 minus 8. Again, you can divide both sides by 4. 0 equals to x cubed minus 8. Negative 8 becomes positive 8 when you bring it to the left. The opposite of cubing something is you take the cube root, so x equals to 2. Again, always form the habit of finding the critical point and not just the x value. If you take 2 and you plug it back into the function, that's going to be 16 minus 64 plus 4, that's negative 44. Now, in terms of the interval of increase and decrease, you can draw a line. Look at the anchor point, x equal to 2. And again, you could pick numbers less than 2, pick numbers that are greater than 2 to figure out increase or decrease. But if you think about the shortcut, again, the derivative is 4x cubed. And 4, of course, means it's going to be positive. And the cube, of course, means odd. So positive odd just means it's going to go from quadrant 3 to quadrant 1, which really means it's going to be decreasing, increasing. And of course, you can verify that if you like. So IOI, the interval of increase, is when x is greater than 2. The interval of decrease is when x is less than 2, just like that. So we found critical numbers, we found the interval of increase and decrease, and the local extrema. So of course, if you think about the first derivative test, the fact that the function is decreasing, then it increases. This is going to be a minimum. And the minimum is 2, negative 44. Now, use graphing technology to verify your results. No problem. Let's do it. X to the 4 minus 32x plus 4. Now if you zoom out a little bit, and if you trace the function, there's the minimum, 2 and negative 44 as expected. Notice the function is decreasing when it's less than 2. The function is increasing when it's greater than 2. So we can double check just by graphing. And that's how you do number 7 and number 6 on page 196. I hope this makes sense.